For this problem, we're going to determine the domain of a rational function and then determine any vertical, horizontal, or oblique asymptotes. We're given the function g of x equals 2x squared minus 14x plus 24 divided by x squared plus 6x minus 40. To find the domain, we need to remember that for rational functions, the domain is always all real numbers except values that make the denominator 0. So we want to start by factoring our function, and we'll factor both the numerator and denominator. In the numerator, we'll pull out a 2 first. That'll give us 2 times x squared minus 7x plus 12. In the denominator, there's no common factor we can pull out, but we can go ahead and factor that as x plus 10 times x minus 4. Continue factoring in the numerator. We get 2 times x minus 3 times x minus 4. Divide by x plus 10 times x minus 4. Now at this point we want to determine our domain. Even though we have a common factor of x minus 4, we need to leave that in there when we determine our domain. We look at our denominator here and see that the values for x that make the denominator 0 will be negative 10 and positive 4. So our domain for this function will be the set of all real numbers for x such that x is not equal to negative 10 and x is not equal to 4. Once we've got our domain, we can go ahead and simplify our function. So in reduced form, we'll say that g of x is equal to 2 times x minus 3 divided by x plus 10, keeping in mind that x cannot equal negative 10 or 4. Find vertical, horizontal, and oblique asymptotes, we'll start with vertical asymptotes. In reduced form, we'll get a vertical asymptote anywhere where the denominator is 0 and the numerator is non-zero. In this particular case, then, we see the denominator is 0 at x is equal to negative 10, so there's a vertical asymptote there. If we check in the numerator, negative 10 does not make the numerator 0, and so it is indeed a vertical asymptote. Next, we'll look for horizontal asymptotes. To do that, we want to consider the degree of the numerator and denominator. We see that the degree of the numerator is 1, the degree of the denominator is also 1, and so we'll get a horizontal asymptote that's equal to the ratio of the leading coefficients. In the numerator, that would be 2, in the denominator, that would be 1, and so we get a horizontal asymptote of y equals 2. Since we can't have horizontal and oblique asymptotes at the same time, we have no oblique asymptotes.